In a previous video, we reviewed the number line. Here, we formalize our intuition about the completeness of the number line. That is, that the number line does not have holes. We treat this as an obvious fact that we assume to be true rather than a theorem that needs to be proved. Let us think about the following sequence of numbers. For every natural number, n, we assign a real number, a sub n. For example, a sub 1 is around 800, and a sub 2 is also around 800. Often, we are interested in what happens to a sequence as we approach very large n. In this plot, there is no clear pattern, and we really do not know what happens. Now, we impose conditions so that all terms in the sequence are between minus 100 and positive 1100. Then, we ask the same question. What happens to the value of a sub n for very large values of n? So, that is the question about the terms in this part of the sequence. For this sequence, we can say that all values will be between minus 100 and plus 1100. Therefore, even for very large n, we can say that it will be within that range. This kind of sequence is called a bounded sequence. Here we have a sequence bounded above and bounded below. Above because of this condition, and below because of this condition. Now we add another condition. Let us say that each term is greater than the previous term, so that a sub 2 is greater than a sub 1, and a sub 3 is greater than a sub 2, and so on. And if we zoom in, we will see that each term is smaller than the next term. A sequence like this is called an increasing sequence. Then we ask the same question. What happens to the value of a sub n for very large values of n? Most people will say that the sequence is likely to approach a certain number, and in this case, that number cannot be greater than 1100. We say that the sequence converges. We write it this way. As n becomes very big, or approaches infinity, the terms in the sequence approaches some number a, which we call the limit. In fact, we can imagine other sequences that are bounded and increasing, and all of them will have to converge. This can be considered as a fundamental axiom that is at the foundation of all of calculus. And the axiom can be stated in this way, that any bounded and increasing sequence converges. In this video, we introduced an axiom that is at the very foundation of calculus. We said that in many cases, we are interested in what happens to a sequence as n becomes very large, or as it approaches infinity. An answer to this question is the axiom that says, any bounded increasing sequence converges. Bounded above means that the terms in the sequence cannot be greater by some value. In this case, it is 1100. Bounded below means that the terms in the sequence cannot be less than some value, and in this case, that is minus 100. Increasing means that each term is bigger than the term before it. And to converge means to approach a single value as n becomes very large. And if a sequence converges to A, we write it as follows. With this fundamental axiom of completeness, we can show that the number line does not have holes, because each point on the number line can be considered as the value to which some sequence converges. In the next video, we will be adding, subtracting, multiplying, and dividing sequences. Again, we will be interested in what happens as n becomes very large.